Hello everyone, January 3rd. Alright, let's do it. By the way, tomorrow I have to go to 2 libraries. Man, another solve the problem. Unique length 3 palindrome subsequence. Given a string S, return the number of unique palindromes of length 3 that are subsequence of S. Note that even if there are multiple ways to obtain the same subsequence, it is still considered at a once. A palindrome is, we know what a palindrome is, we know what a subsequence is. So we want to return the number of unique palindrome of length 3 that are a subsequence of S. Basically, just pick 3 indices, right? You pick 3 indices and it has to be a palindrome. So we want to find out how many there are. So in this case, AABCA, right? So palindrome number 3, basically we need to find 2, right? We need to find the first one, we need to find the third one, and in the middle, it doesn't really matter. So in this case, we have an A, so we need to try to find another A that is at least 1 apart. So we find this A, we have this A, so we have 3, right? That's it. This say we have this, so I have 2. B only have 1, C only have 1, so the answer is 5. But the answer is not 5 because... Wait, why the answer is not 5? Oh, unique palindrome. If there are multiple ways to obtain the same subsequence, so it's not indices, but the same values, right? The same values. Okay. It's fine because the only possibility is A something A, B something B, right? All the way to Z something Z. And each one we have A to Z. So the total number, we even know the total number of all possibilities. So basically, we can say what has been found. So we can do an array of array, right? We do an array of array, which is 26 by 26, okay? So the first row will be all corresponding to A, and then we just say if this has been, yeah, we can do but then we have to go through them, right? Interesting. Now we have to go through them. Well, we find the most apart, right? If we have multiple A's in between, we just find the one to the most to the, we find the pair that's most to the left and most to the right. Okay, we do that. That's the pair we want to find, the smallest index and the largest index. And then anything in the middle, how do you know how many different letters are in the middle? That is a good question. We can do a counter. Yeah, do a counter. Number of unique letters. Right, this is what we want. We want to find the number of unique letters between 2 indices. Okay? Can we do that as a prefix sum? So number of unique letters. Let's do this. Number of unique letters. 1, 2, 3, 3. Right? That's the number of unique letters. So I find this and this. So we need to find the unique letters in the middle. So we do this minus this. So it'll be 2. That's not right. The unique letters up to here is 3. But if I do, yeah, I want to know in between this, like what is the number of unique letters in this range, right? In this range. I mean, I can't just. That's a good question. How do we know the number of unique letters? Because this is the number of unique letters from the start to here, right? And from start to here, so based on what this one, hold a second, let me think again. The number of unique letters. I know from the start to me, I have certain number of unique letters, right? And then I, cut off some of them. Yeah, that actually does not sound right. It's not 2, right? It's not 2. How do I find the number of unique letters? Okay, there is a dumb way, I think, a very stupid way to do this. We can count the number of letters, basically, right? The number of letters. Yeah, so if we want to do this, we can count 26 times. For each one, we know the number of, we have the counter. So like for A counter, right? So for A, 1, 2, 3. For the count is 1, 2, 2, 2, 3, right? So 1, 2, 2, 2, 3. So for the number of A's in between here is 2 minus 1 equal to 1. So we know there's a 1A here. So we do B, we do the same thing for B, we do the same thing for C. Now we know in this range, right? In this range, I have A, B, C, right? 3 unique letters. So that would be counting 3. And that's it. A is done, right? A is done. And we just move on to the next one, B. And B doesn't have, C doesn't have, and then the answer is 3. Okay, so that will work. And the runtime will be 26 times 10 to the 5th. Now, I am not sure. You know what? Hold a second. It's not. Okay? We do ON. We will produce the first and the last, right? For each one. Yeah, that's like ON. And then we go through as 26 times 26. That's not true, because as we do, no, that's true. As we do ON, we need to fill out this thing, right? So basically for each letter, we go through, and no, I think we can do it in one pass, right? Yeah. So we create this array of array, and then if it's this, we'll do, now we have to go through them, every single one of them, which is okay. All right, that's one way. Okay, that's one way. So we have a way, but I don't like it. Right? I definitely don't like it. I think there should be an easier way to decide the number of unique letters in a range. How do I know the number of unique letters in a range? Yeah, let's say we can say the number of unique letters up to this point, I know is a certain number, and up to this point is a certain number. If this 2 is the same, and that doesn't really mean anything, right? It just means if I remove everything in before, that should only be 1, right? That's only 1, and Yeah, it doesn't really matter. It won't work. It will not work. What else can you think? That's all you want. The unique letters. Well, I don't know. We're gonna find the unique letters. Can't we just go through them? We can just go through them. Alright, it's just the same. 26 times n. We find the pair. That will take O(n). And then we'll go through every single pair. And we just go through in between and then just count how many unique letters we have. Yeah, exactly. I mean, it's fine. Yeah, this is okay. Yeah, I'll do it that way. Yeah, that's fine. So, here's the question. Does C++ have any helper function to count the unique characters in a substring immediately? Right? If not, I can try. C++ find unique character in string. Is there a function to do this? Otherwise, I guess we just have to. I am not using set. I don't think there is. So they're using set. Okay. Alright. Doesn't matter. Does not matter. Let's just do it. We'll do it using the method that I had in mind. So first things first, what we're gonna do is create a Can I do an array? Oh, I don't think I can. Yeah, I really don't think I can. So I shall do a vector of std, vector of int, right? And we use this to say indices. I should know it's gonna be 26 and vector int. I'm not sure if this is correct. Maybe I need to do this. Okay, so this is indices. And we're gonna go through them for int I equal to 0, I smaller than s dot size, I plus plus, right? So I know what it is. Let's say if yeah, I just need the first one, and I need the second one. This is actually size of 2, right? So basically, I say indices si minus a, okay, 0 shall equal to std minimum. You know what? That should not be the case. I shall put, let's do this way. The first one is the minimum, so I shall do integer max int max, yeah, int max, and next one we can say int min, right? And then we'll do and as int j equal to si minus a. I know all of this is just trying to make the whole thing, the whole experience, a little bit better, right? A little bit better. We can say indices j 0 I, indices j 1 td max j 1 I. Okay, and then we go through everything. Okay, so now we have our indices, and then we go through them one by one. We have interest equal to 0. Okay, we say for we just need to find in between this how many, right? How many? We say we can do auto actually, right? We can do auto. Yeah, I think we can do auto. Low high of indices. If low is smaller than int max and high is larger than int min, std vector of boolean value seen with the 26 of false, right? Then for int I equal to low I smaller equal to high. Actually, that's not right. I'm gonna do that. Plus 1. Actually, if this and this, I have a better idea. It should be high minus low, right? High 0, 1, 2, right? 0, 1, 2 minus low should be larger or equal to 2, right? So we do that. I plus plus. If not seen string I, not string I, si minus a, right? If this has not been seen before, rest plus plus and seen si go to true, right? If it is, I have seen before, so we I think we cannot do it this way. Alright, that's fine. So auto pair. Okay, so int high go to pair 0. Low is pair 0. High is pair 1. Okay. Blah 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 blah, and return rest. All right. So let's see. Is this correct? Okay, that's a little typo. Try it again. Oh Lord. Oh Lord. Min -1. I cannot do it that way. Are you kidding me? What's the error? Cannot be narrowed from size type to. Oh, I think I need to cast it into int. There you go. That is the one. Let me put it here and write some stuff. It's 1930, right? We find the left and right most indices for a given letter, then count the number of unique letters in between. The answer is the sum of all those unique letters. Well, it's on and a plus indices is 26. Right, and then 26n, basically. So it's on, still on. All right, let's see if this one is, let's run it one more time. Make sure that everything works. Looks like it worked. Submit it. And we pass. Oh, it was actually pretty good. 71 milliseconds, 71, 93, 87. 9387 percentile. Alright, guys, pretty good. Let's see. I did it before November 14th. I have Java. I think it's about the same. Man, I don't even remember how Java is working. Binary search. Ooh-wee. What the hell? What did I do? I see. I get the indices for every single one. And then I check if it's logical to 2. That's correct. I get a current index. That is correct. Get a smaller, get a larger. That's correct. If that's correct, go through them. Find the index in its thing. If its current indices is larger equal to 3, index is larger than 0, current indices is larger equal to 3, or we don't find any, okay, I don't understand this part. And why is larger than 1? Larger than 1 is the same as larger equal to 2. And then we go through every letter. Indices, I'll get that. Try to find the mean. Okay. If this means I have a match. Oh, this means we are matching the same letter, right, as the small and large, and then we increment. If we don't find anything, then we are basically checking if there is anything in it. Then we do. Okay, yeah, it's the same. It's exactly the same. Not exactly the same, but very, very similar. Official solution. left and right of the 3-length palindrome. So use a set, right? Pick a letter. Well, this one, this, and this is not equal to C, I plus plus, and then come out. If I is larger or equal to, okay, otherwise do J, the same thing back and front. Got it. And then we do a set. Go through them, count the size. Yeah, that's exactly the same. All right, pretty good. Call it. Now we come back to this one, and we need to check the solution because I don't know how are the good solutions. Oh, yeah, this is actually a good change by, putting in here. Oh, you don't have to do log n. Where is the log n? I have a bisect to log n. See, I don't know how. Holy crap. Did you write it this way? Enter side-by-side mode. Copy link. How do I open it by itself? It's kind of stupid. All right, let's see. We can do this. Count will count the frequency of this. Enumerate SSR. Update count first. For each this, result plus equal to count. Return rest in the end. So we have a counter. We will count the number of ratios. Okay, R have these. Q is this. P is up to Q. Then we try, so for R, we try every single one, and we try every single S. I am not sure. Isn't this one R and Q are set in stone? So he's saying R and Q are set in stone. They must differ by 2. So Q something R. Why? Why? There is a reason. For a given R, the possible PQ combination can be calculated from the previous loops, not necessarily need to calculate the current loop. What do you mean? Basically, it's for every single. So given R, we basically go through every single Q as well. Right? Because if R is here, we hit everything. This P, like we go through the P, right? We go through the P, we put the R is here, and then we put in here, we go through everything here, we put in here. So every single R, we go through all the PQ combination, all the PQ combination, all the PQ. So we get all the PQ combinations. That is actually correct. Okay, that is actually correct. And then we can do the count of all the PQ combinations. Right? We do the count of all PQ combinations. We do all the count of PQ combinations, and then we do all the count of RS combinations. And for each one, for each RS, we just find how many PQ we have so far. Jesus, this is so good. Holy crap. Yeah, because you're just counting that. You just want to find all possible pairs, right? All possible PQ pairs. And by doing that, you set a Q value and you go through all the P's with this Q. And then you have the next Q, you go through everything with this Q. And the next one, you go through everything with this. So you just do all of them, right? You go through all of them. So whenever you are at an RS, all the previous PQ combinations, they're all done. Dude, this is so good. This is so good. Where do I upvote? Jeez Christ, man, this is so good. Alright, so we know the O(n) square solution. We'll leave it be, because do you want to do it today? Do ya? Actually, I actually do, man. I feel it. I feel it in the water. I feel it in the air. And I will do it. What's that? We'll do this. See, that's the problem. I need to. Oh, hold a second. I have a link. I do have a link. This solution is from Lee215. Let's put the link to his answer. We copy the link. Right? The key is to iterate with R. Right? And for each R position, we can iteratively accumulate the count of all nums P divided by nums Q, right, to the left of R. Then we iterate, then we go through S, right, and for each nums R divided by nums S, we add the count from nums P divided by nums Q. Alright, here's the question. He uses the division directly to do. Oh, hold a second. Python float as key, as dict key. I don't know if it's possible. 10 years ago. What is this? I don't want it. I want to do it the stupid way. Okay, I want to do it a little bit dumb. Basically, I'll do a counter, and I'll just use GCD. So we say counter equal to ratios counter. Okay. Then for R in range, yeah, 0, 1, 0, 1, 2, 3, 4. 4 all the way to len nums. Okay, we probably say n equal to len nums. And this will be n minus r. Minus 1, minus 2, minus 2, right? So this is this for r. And then q equal to r minus 2. For p in range all the way to q minus 1, right? We say counter, not counter ratio. G equal to master GCD, nums p, nums q, right? And ratios p divided by g, q divided by g plus equal 1, right? We need a result. For s in range r plus 1 to n, g is math GCD, nums, I remember is s divided by r, so s nums r, right? Then ratios, nums p, this is nums q, right? So ratios nums s, g nums r, g rest plus equal to this, and at the end return rest. Type annotation, counter on squared. The brilliance of this solution is to use R as the anchor for the iteration and use counter to quickly find the number of subsequences. Oh, we already have solution. This is before. 4 already exists. Oh, you gotta be kidding me. They all exist. This is solution 6. Dude, man. Solution 6. Alright, let's take a look. We only have 3. Do we have more? We have result not supported. Yeah, it's actually it's not even correct. Alright, something is not right. The GCD is not right? I don't think so. R plus 2, my bad. There we go. This is your solution. Super duper fast. Should shave off about a quarter. Not really a quarter, but close enough. Yeah, this is 2220. I think 2220 is good. 2220 is good. Right? This is 2220 milliseconds with a 37.42 percentile. Alright, that's good enough. If you look at the submissions, we went from 9,000, Jesus, to 4,000, to slightly better, 37 to 22, yeah. And the memory usage is getting lower and lower each time. I bet, I don't know. Okay, here is the thing. I'm gonna do something risky. What if I go ahead and directly do divide? I'm actually not even sure. I forgot. Is I don't know, 5 divided by 2. Oh, is it 2.5? So we are not using GCD at all. Earlier I think it's an 87 millisecond or something like this. Let's see what we get. 39 milliseconds. So without GCD I think it's faster. Still, I mean, I was searching for Python using float as a key dict, but I'm not quite sure. I need something, restriction on dictionary key and values. Oh, it's restricted. I think I have an account with them. Oh, I have to subscribe, right, to unlock. I just want to know if is this safe? Dict key requirement. I didn't say about float. Is float hashable? Actually, I'm not sure. Can I do this? Type 5? I cannot do that. Okay, type class int 5 divided by 2 class float this dot hash needs an argument. How do I check the hash? I can use the hash function. Hash object. Okay, so we can say hash 5 divided by 3 hash 5 divided by 2. Yeah, I guess it is hashable. Huh. Okay, so we don't even need. Alright. Okay, update without using GCD, directly using float as key. I bet this will be faster. There we go. There we go. That is the ultimate. That is the ultimate. Solution 7. Okay, this is solution 7. Solution 7. And yeah, same as solution 6, but directly use float as key. Oh, we got this one. 1405. 1405. And I think 79.17 percentile. Okay, now I'm happy. Done, basically, this problem. Good. We'll upvote it and move on. I believe previous question is previous question. Yeah. We'll just put it here. We might come back for this. Alright, that'll be it for today. I will see you guys tomorrow. Adios.